Did you know that most of the AI systems deployed in production today contain measurable bias that affects real people's lives? From loan applications being rejected based on zip codes to resume screening tools that discriminate against women, AI bias is everywhere. But here's the thing, you don't have to be a bias detection expert to fix this problem. Today, I'm going to show you 5 powerful Python tools that can detect and fix bias in your machine learning models. Whether you're building your first classifier or managing enterprise-scale deployments, these tools will help you build fairer AI systems. We'll start with IBM's comprehensive toolkit that offers over 70 fairness metrics, then move to Microsoft's solution that works perfectly with Scikit-learn. After that, we'll explore Google's visual analysis tool that requires zero coding, and finish with Infosys' modular approach that goes beyond just bias detection. By the end of this video, you'll know exactly which tool to use for your specific needs and how to integrate them into your existing workflow. Let's dive in and make AI fairer for everyone. Let's start with the heavyweight champion of bias detection, IBM's AIF 360. This toolkit is like having a Swiss Army knife for fairness. It contains over 70 different fairness metrics and bias mitigation algorithms. Think of it as your one-stop shop for everything related to AI fairness. The first thing that makes AIF 360 special is its incredible range of fairness metrics. You get statistical parity, which checks if different groups receive positive outcomes at the same rate. There's disparate impact, which measures if one group is significantly more likely to receive negative outcomes than another. And equal opportunity metrics, which ensure that qualified individuals from different groups have equal chances of receiving positive outcomes. But here's where it gets really interesting. AIF 360 doesn't just tell you about problems, it helps you fix them. The toolkit offers 3 different approaches to bias mitigation. Pre-processing algorithms modify your training data before you even build your model. For example, if you notice that certain demographic groups are underrepresented in your training data, pre-processing algorithms can rebalance your dataset. In-processing algorithms work during model training, adjusting the learning process to ensure fairness. These algorithms modify the loss function to penalize biased predictions while maintaining accuracy. Post-processing algorithms fix bias after your model is already trained. They adjust the final predictions to ensure fair outcomes across different groups. Now let's talk about the technical setup. Installing AIF 360 is straightforward. Just run pip install AIF 360 in your terminal. But here's something important to remember. AIF 360 requires protected attributes to be encoded as integers. So if you're working with categorical data like race or gender, you'll need to convert these to numerical values first. This is different from how you might handle categorical data in other machine learning libraries, so keep this in mind. The real power of AIF 360 shows when you integrate it with your existing workflow. It works seamlessly with Scikit-learn and Pandas, which means you don't need to completely change how you work. Let me give you a practical example. Imagine you're building a credit scoring model and you want to ensure it's fair across different age groups. You would start by loading your data into AIF 360's standardized dataset format. Then you'd use one of the fairness metrics to measure bias. Let's say disparate impact. If you find bias, you can apply a pre-processing algorithm like reweighing to balance your training data. After training your model, you can use post-processing techniques to further ensure fair outcomes. The entire process integrates smoothly with your existing Pandas and Scikit-learn code. Now let's move to Microsoft's Fairlearn, which takes a different approach. If AIF 360 is the Swiss Army knife, then Fairlearn is the precision tool designed specifically for Scikit-learn users. The biggest advantage of Fairlearn is its seamless integration with Scikit-learn. If you're already using Scikit-learn for your machine learning projects, Fairlearn will feel like a natural extension. Fairlearn focuses on core fairness assessment capabilities that cover the most common use cases. It provides demographic parity metrics, which ensure that different groups receive positive outcomes at similar rates, and equalized odds metrics, which ensure that the model's accuracy is consistent across different groups. But here's what makes Fairlearn special. Its built-in visualization tools. These tools automatically generate charts and graphs that show how your model performs across different demographic groups. You can instantly see if your model is treating different groups fairly without writing complex visualization code. For example, if you're analyzing a hiring model, Fairlearn can show you exactly how the model's predictions vary across different demographic groups. You'll get clear, easy-to-understand charts that you can share with stakeholders who might not have technical backgrounds. Fairlearn also offers reduction algorithms for bias mitigation. These algorithms work by transforming your original machine learning problem into a series of cost-sensitive classification problems. The beauty of this approach is that you can use any Scikit-learn classifier as the base estimator. So if you're already using random forests, logistic regression, or any other Scikit-learn algorithm, you can easily make them fair using Fairlearn's reduction algorithms. The integration with existing Scikit-learn pipelines is where Fairlearn really shines. You can drop Fairlearn's algorithms directly into your existing Scikit-learn workflows. This means you don't need to rewrite your data pre-processing pipelines or change how you handle model evaluation. Let me show you how this works in practice. Suppose you have a Scikit-learn pipeline that pre-processes data, trains a classifier, and evaluates performance. To add fairness constraints, you simply replace your original classifier with Fairlearn's reduction algorithm. The reduction algorithm wraps around your chosen Scikit-learn classifier and automatically handles the fairness constraints. Your pipeline continues to work exactly as before, but now it produces fair outcomes. Now let's explore something completely different. Google's What If tool. This tool is perfect if you want to analyze model fairness without writing any code. The What If tool integrates directly with TensorBoard, Google's visualization platform. This means you get a powerful, interactive interface that runs right in your web browser. The tool's strength lies in its counterfactual analysis capabilities. Counterfactual analysis helps you understand what would happen if you changed certain features of your input data. For example, you can ask questions like, what would happen to this loan application if the applicant lived in a different neighborhood? Or, how would the model's prediction change if this job candidate had a different name? These counterfactual questions help you understand exactly how different features influence your model's decisions. The real-time performance visualization is another powerful feature. You can see how your model performs across different subgroups instantly. As you adjust parameters or change input features, the visualizations update in real time. This makes it easy to spot bias patterns that might not be obvious from looking at aggregate statistics. The browser-based interface makes fairness analysis accessible to non-technical team members. Product managers, designers, and business stakeholders can explore model behavior without needing to understand Python code. This is huge for organizations where technical and non-technical teams need to collaborate on AI fairness. Setting up the What If tool requires a TensorFlow and TensorBoard environment. If you're already using TensorFlow for your machine learning projects, setup is straightforward. You'll need to save your model in TensorFlow's saved model format and prepare your data in a compatible format. Once everything is set up, you can load your model and data into the What If tool interface. The tool automatically computes various fairness metrics and presents them in an easy-to-understand format. You can slice and dice your data by different demographic groups and see how model performance varies. The tool also provides feature importance analysis, helping you understand which features contribute most to biased predictions. Let's move to something that goes beyond traditional bias detection, the Infosys ResponsibleAI Toolkit. This toolkit takes a holistic approach to AI responsibility, covering areas that other tools often miss. While bias detection is important, responsible AI includes much more. The Infosys toolkit covers safety, ensuring your models behave predictably in edge cases. Security features help protect your models from adversarial attacks. Privacy modules ensure that your models don't accidentally leak sensitive information. And explainability features help you understand why your models make specific decisions. But here's something really interesting. The toolkit includes hallucination detection. This is especially important if you're working with large language models or any AI system that generates text. Hallucination detection helps you identify when your model is making up information or providing unreliable outputs. This feature works for both traditional machine learning models and modern LLMs. The toolkit uses an API-based integration approach. This means you can easily incorporate its features into your existing Python pipelines without major code changes. Each module exposes simple API endpoints that you can call from your existing code. The modular architecture is another key advantage. You don't need to adopt the entire toolkit at once. You can start with just bias detection, then gradually add other modules as your needs grow. This makes it much easier to adopt responsible AI practices incrementally. For example, you might start by using the bias detection module to audit your existing models. Once you're comfortable with that, you could add the explainability module to help stakeholders understand model decisions. Later, you might incorporate the security module to protect against adversarial attacks. The API-driven approach also makes it easy to integrate with different deployment environments. Whether you're running models in the cloud, on-premises, or in edge devices, you can use the same API calls. Now comes the crucial question: which tool should you use for your specific situation? Let me give you a decision framework that will help you choose the right tool. If you need comprehensive fairness metrics and want the most complete bias detection capabilities, go with IBM AIF 360. This is especially true if you're working on high-stakes applications like healthcare, criminal justice, or financial services. AIF 360's 70+ metrics give you the depth of analysis needed for these critical applications. The tool is also ideal if you're doing research or need to comply with strict fairness regulations. If you're already heavily invested in the Scikit-learn ecosystem, Microsoft Fairlearn is your best bet. The seamless integration means you can add fairness constraints to your existing pipelines with minimal code changes. Fairlearn is perfect for production environments where you need reliable, well-tested algorithms that work with your existing infrastructure. If you have non-technical stakeholders who need to understand model behavior, choose Google's What If tool. The visual interface makes it easy to demonstrate fairness concepts to business users. It's also great for exploratory analysis where you want to quickly understand how different features affect model fairness. For comprehensive responsible AI beyond just bias detection, the Infosys Toolkit is your answer. This is especially important if you're working with LLMs or need to address multiple aspects of AI responsibility. The modular approach makes it easy to adopt responsible AI practices gradually. Now let's talk about integration considerations. Each tool has different technical requirements and setup procedures. AIF 360 requires careful data preparation, especially for protected attributes. Fairlearn works best if you're already using Scikit-learn workflows. The What If tool needs TensorFlow and TensorBoard setup. The Infosys Toolkit requires API integration planning. Here's a pro tip: you don't have to choose just one tool. Many organizations use multiple tools for different purposes. You might use AIF 360 for comprehensive bias auditing during model development. Then switch to Fairlearn for production deployment because of its Scikit-learn integration. And use the What If tool for stakeholder presentations and exploratory analysis. The key is to understand each tool's strengths and use them where they provide the most value. In production environments, consider using AIF 360 or Fairlearn for automated bias monitoring. These tools can be integrated into your MLOps pipelines to continuously monitor model fairness. You can set up automated alerts when fairness metrics fall below acceptable thresholds. For model governance and compliance, having comprehensive documentation from tools like AIF 360 is crucial. The detailed metrics and reports can help demonstrate compliance with fairness regulations. Remember that bias detection is just the first step. The real value comes from using these tools to iteratively improve your models. Start by establishing baseline fairness metrics using your chosen tool. Then use the mitigation algorithms to improve fairness while maintaining model performance. Continue monitoring and adjusting as your models evolve and new data becomes available. We've covered a lot of ground today, from IBM's comprehensive AIF 360 toolkit to Microsoft's Scikit-learn-friendly Fairlearn. We explored Google's visual What If tool and Infosys's modular approach to responsible AI. The key takeaway is that you now have multiple powerful options for detecting and mitigating bias in your Python machine learning workflows. Remember, building fair AI isn't just about using the right tools. It's about making fairness a core part of your development process. Start with one of these tools that fits your current setup. Begin measuring fairness in your existing models and gradually expand your responsible AI practices. If you found this video helpful, make sure to like it and subscribe for more practical AI tutorials. Leave a comment below telling me which tool you're planning to try first, or share your own experiences with AI fairness tools. In the next video, we'll dive deep into implementing these tools with real-world examples and code walkthroughs. Until then, keep building AI that works fairly for everyone.